Here we are going to correct some exercises. So let's take a look at the exercise 11. Here they are saying identify the correct products for the following neutralization reaction. This reaction, it is neutralization reaction, and neutralization reactions occur always between an acid and a base. An acid, so neutralization, it is always acid plus base will give us salt plus water. This is neutralization. Okay, this is a rule, and this is what we have to find out in the end. What is an acid? HCl is an acid. Why? Because it starts with an H and it is linked to a halogen element. Always H with a halogen, it is an acid. Okay. And what is the base? The base, it is this one. Why? Because this one, it is ends with OH, and we have a metal. Metal with OH, always it is a base because the OH, the hydroxide will be released. So what will be the neutralization? Yeah, we're going to, as we said, it is water plus, but we're going to find it by using the double displacement. First, we have HCl plus MgOH, like this one. So I'm going to take HCl here, and I'm going to put HgOH to here. First, HCl will dissolve, and it is an acid. An acid, what will give us? It will give us a proton H plus and Cl minus. Another way to find it, because the ions that will give us, it will give us H plus and Cl minus. Cl minus, why? Because you can go to your periodic table again, and you have the chlorine. It will give you the negative, and the hydrogen, it can be positive or negative, but in this time, because it is in the acid compound, it gives us positive. What about MgOH? We'll have Mg and we'll have OH. I'm going to keep the OH in the brackets. The Mg, it is magnesium. What is the charge of the magnesium? The magnesium, it is, I'm going to erase everything because it's a mess now. Okay, where is the magnesium? It is here. What is the charge of magnesium? 2. So this one, it will be plus 2. What is the OH? OH, it is polyatomic. You remember, you have to memorize these elements. OH is polyatomic, it is hydroxide, and its valence or its charge, it's -1. So it will be here -1. So what will happen now? What will happen? This H plus will go with OH minus. So this positive will go with this negative, they will change partners, and this negative will go, this negative will go with this positive here. So it is double displacement. Why? Because both they are changing partners. This one will go with this one, and this one go. It is double displacement. So what we'll get up in the end? This is the first step. The second step, what we will end up with? We'll end up with H plus going with OH minus, and we're going to end up with Mg plus, Mg2 plus, going with Cl minus. Always we put the pluses, the positive in the first place. That's why I switch them. So these two here will form a compound. There is no problem here because we have +1, -1. The charges cancel each other. So we have no problem to give us HOH. But what is HOH? HOH is H2O. This is HOH. So we'll get HOH, we'll get H2O. What about this ones here? This one, it is 2 plus. I'm going to put it +2. I prefer to plus it +2. And this one, it is -1. So the charges doesn't cancel because +1, -1, it doesn't cancel. How do you cancel them? We multiply this one by 2. If I multiply the up by 2, I have to put a 2 on the bottom here. Now the charges are canceling. Why? Because +2 -1 + 2, it gives me 0. These ones will cancel. So I will end up with what? I will end up with Mg. I'm going to write it with the other. I will end up with MgCl2. So this is what I will get. I will get MgCl2 and water. So I'm going to write it here. MgCl2 plus the water, H2O. And this is what we said we have to find. We said that we had to find, so I'm going to erase this one here. We don't need them anymore. You recall, we said acid plus base, an acid An acid plus a base must give us what? Salt plus water. And this is what we get. So this is neutralization, and it is a rule. Now we're going to correct also this exercise 12. So what they are saying here, write a balanced chemical equation for the complete combustion of C5H12 in oxygen O2. Combustion, it is what combustion? It is burning. You burn something. And you are two ways that you are burning things. With complete burning, complete combustion, or incomplete combustion. We have two. When you are burning things, sometimes if you are not if you don't pay attention and if you are not careful, you can end up with a problem. Always you have to end up with a complete combustion, not incomplete combustion, because incomplete combustion produces carbon monoxide, which is a poison. Yeah, it is, and by law you have to make detectors of carbon monoxide, etc. Okay, so what is complete combustion now? So I'm going to put some rules again. Rules. Complete combustion. Complete combustion. When you have complete combustion, you are burning something. So I'm going to write here something. You are burning it. How are you going to burn it? By adding oxygen. It gives you always CO2, carbon dioxide, plus water. So this is the rule. When the combustion is complete, always we'll have something that we are burning, plus O2 will give us carbon dioxide and water. It will not give us anything else. Now, what about incomplete? So this is complete combustion. Incomplete combustion. Combustion. I am burning something, put it something, paper or gas or anything, plus O2, what will give me? It gives me at least carbon, CO, CO2, and water. The mandatory ones, it is, I'm going to put the ones that always I will get always this one. I will get at least one of them. And sometimes you get for incomplete, this one we can get it or not. Okay, but for incomplete, at least carbon or CO or both. But if you don't have carbon or you don't have CO, the reaction is complete. So for the reaction to be incomplete, we must end up either with carbon or CO or both of them. Understand? This is incomplete combustion. So now we understood what is incomplete combustion. And complete combustion, we are going to answer the question. So what they are saying? They are saying that we are burning COH12. So C5. What is it? C5H12. We are burning C5H12. So we are adding oxygen. It will give us CO2 plus water. Why would give us this one? Because it is complete, and we said for complete always we'll get CO2 plus S2. Now they are asking us to give them a balanced one, so I'm going to write it here. C5H12 plus O2 will give me CO2 plus H2O. This is what it will give me, CO2. So we have to balance it. I'm going to use the bases to balance it. So I'm going to write it here. C5H12 plus O2 will give me CO2 plus water. And we have now to put the bases. So I'm going to put the bag here. I'm going to put a big bag because I have lots of hydrogens there. How many carbon? 5. 1, 2, 3, 4, 5. How many hydrogens? 12. 1, 2, 3, 4, 1, 2, 3, 4, 1, 3, 1, 2, 3, 4. So 12. How many oxygens I have? 2 here. How many monoxide of carbons? Carbon monoxide. Dioxide. I have 1 carbon, 2 oxygens. How many waters? How many? The back of the water. I have 2 hydrogens and 1 carbon, 1 oxygen. So now we are going to start balancing. How many carbons I have? 5. I have only 1 to it. So I'm going to add 4 other bags to add up with 5. 1, 2, 3, 4. Now I'm going to balance the hydrogens. How many hydrogens I have here? I have 12. I have here 2, 2, 4, 6, 8. How many hydrogens? 12. 10 and 12. Double check. 1, 2, 3, 4, 5, 6. 6 times 2, 12. So the carbon are okay, the hydrogens are okay now, but the oxygens, I'm going to see how many oxygens I have. I have here 2, 4, 6, 8, 10. 10 plus 2, 12. 12, 14, 16. I have 16, so I have to add bags until 16. I have already 2 here. I'm going to add another 2, so it will be 4. Here 6. Here 8. 10. 12. 14. 16. And then everybody is okay. Yeah, the carbons are okay. I did nothing to change their state. Hydrogens are okay. Did nothing to change their state. Oxygens, they are the last one that I balanced. So everybody is okay. So how many bags I have here? I have only 1 bag. So I'm going to put 1 here. How many bags here? 1, 2, 3, 4, 5, 6, 7, 8. So it will be 8 here. How many bags here? 1, 2, 3, 4, 5. Right. How many bags here? 1, 2, 3, 4, 5, 6. I have 6 here. And then I'm going to put in the numbers. So here we have 1 here. It is useless. We don't going to put it. I have 8 here. I will put it. I have 5 here. I will put it. And I have 6 here. I will put it. So I balanced the equation for the complete combustion. Good. This one, it is good. Now we are going to speak about incomplete combustion. Incomplete combustion, what we are burning, the same. C5H12. This is what they are saying. Use the same reactant and write a balanced chemical equation for the incomplete combustion. Yeah. So we have to add O2. And this time, which will give us? It will give us carbon. Carbon. I don't have to put the both of them. I don't have. I can put only one, but I'm going to put both of them because it will help us balance. I will put CO2 and water. Yeah, this is the incomplete combustion. Again, I have to put only one of these two. I don't have to put this one, but water, we have to put water. Why? Because the hydrogens will go. They have to go to form water. So, but this one, I don't have to put it. These two, I don't have to put both of them, but I have to put one of them at least. But here, I'm going to put everybody. Okay, so I'm going to put them here. C5H12 plus O2, and I'm going to balance it here. So I'm going to build the bags is here. What is this bag here? I have how many? 5. 1, 2, 3, 4, 5. How many hydrogens? 12 again. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I have 12 here. Good. How many oxygens I have? Oh. How many carbon here? I have only 1. So I have 1 bag of carbons. I have 1 bag with carbon and oxygen. I have 1 bag with carbon and 2 oxygens. And I have 1 bag with 2 hydrogens and 1 oxygen. And now we are going to start by balancing. I'm going to start with carbon. No, it is not. Yeah, we can start with carbon, but it is not a good idea. Why? Yeah, I'm going to start because I don't want to enter in the... How many carbons I have here? 5. But here you see I have only one carbon. That's why I'm going to leave it in the end. When you have an element, a bag with only one kind of element, leave it in the end. Like the oxygen here, I have a bag here with only oxygens. I will leave oxygen and the carbon in the end. Why? Again, I have one bag with one element alone. So I will leave the carbon until the end. The oxygen also I'm going to leave them until the end. Why? Because they have only two carbons. So I'm going to start by balancing the hydrogens. How many hydrogen I have here? 1, 2, 3, say 12. How many hydrogens? I have only 2. So I'm going to add back this. HHO. Now how many hydrogens? 2, 4, 6, 8, 10, and 12. Good. Now the oxygen, the hydrogens are okay. Now which ones I'm going to start with? With the oxygens. Why? Because this one has only one carbon. I have a bag with only one element. I will leave it in the end. This one I have a bag with two elements. They are the same. Very good. But they are two. So I'm going to balance the oxygens. How many oxygens I have here? 2. How many oxygens I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 oxygens. I'm going to recall again. How many hydrogens I have? 2, 4, 6, 8, 10, 12. Yeah. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have 9 oxygens. So what I have to do here, I'm going to add until I reach 9 or more. So I have 2, 4, 6, 8. No chance. I have to add another bag because if I stopped here, I will have 8 oxygens. But here I have 9. So I have to add another bag. It is always more to have more than not enough. Okay, it is always good to have more than enough. So I have now 10 oxygens, but here I have only 9. So what I'm going to do, I will add another bag here with this one here. Now how many oxygens I have here? Now I have 10, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The oxygens are okay. The hydrogens are okay because I did nothing to change the state. The hydrogens are in the water. I did nothing to change the state. So now I go to the carbon now. How many carbons I have here? 1, 2, 3, 4, 5. How many carbons? 1, 2, 3, 4. I add another carbon here. And that's it. How many carbons I have now? 5. Here 5. How many hydrogens? Hydrogens are okay because I did nothing to change the states. Oxygens also, they are balanced because I did nothing to change the state because I added only one bag with carbon. This bag here will not change the state of oxygen, will not change the state of hydrogens. So everybody is okay now. So I find my numbers. So this one I have one bag, so put one here. How many bags here? 1, 2, 3, 4, 5. I will put 5 here. How many bags here? 2, 1, 2, 2. How many bags here? 1, 2, 2. How many bags here? I want 1. How many bags here? 1, 2, 3, 4, 5, 6. And I have 6 bags here. So this is, so now the bags I can remove them. I don't need them. Good. And that's it. So everything now it is balanced. And this is my reaction. Now we have to clean up our reaction. This one here, it is useless. I don't have to put it. This one here, it is useless. I don't have to put it. And this is my answer. This is the answer, so you can write it here if you want. So this is for this video. And there we study how many questions left. We are at 12. Yeah, so we are almost done. It is 15 left, and you are done. Good. So do more of these exercises. Replay the video, understand what is complete combustion is and what is incomplete. Why incomplete combustion it is dangerous? As I said, because it gives us the carbon monoxide, and the carbon monoxide it is toxic. Why it is toxic? It's a poison. Why? Because it is it is like oxygen. Oxygen has two molecules. Carbon here has two. Carbon and oxygen, it is almost alike. Why? Because they are neighbors in the periodic table. You see the carbon here and oxygen here. So it is. So in the blood, the blood can't differentiate between this one and this one. And the blood sometimes it's carrying this one for the cell, thinking it is carrying oxygen. What happens to the cells that get carbon monoxide instead of oxygen? They get poisoned, and the cells they die. That's why it is dangerous. That's why by law, in your house you have a carbon monoxide detector, and it is not wise to burn anything inside the house. You have to burn it outside, because inside the house you have more probability to have incomplete combustion than complete combustion. That's why barbecues, always you have to do your barbecue outside, not inside. Okay, this is for safety reasons. So this is okay. Okay, go. So this is it now. This is it. Okay, bye.